Hi, welcome to the fun probability problem solving sessions. And today we are going to work on very interesting problem. And this is, this ones here is they said that x has a discrete random variable, and the x belong to the natural number 1, 2, 3, and continue. Suppose the distribution of the x is memoryless. That means so given that x equal to n plus m, given that x or greater than m is equal to the probability x equal to n. So we want to prove that x has a geometric distribution. The reason why I say this problem is interesting, the problem is because typical, from the very classical proof in the probability theory is we have a random variable, it's with either exponential distribution or geometric distribution, then we can prove the memory list. Then this ones here is go backward. So they tell you if a random variable is memoryless, then I want to show this random variable have a geometric distributions here. All right, so let's take a look. How do we do this type of problem? It's very interesting. Like I say, it's a typical we show if you give me a geometric or exponential, I can prove that it's memoryless. But now you say, if it's memoryless, how do I prove that it's geometric? It's very, very interesting, the problems here. Okay, so now let's go ahead, go to our whiteboard, and let's start. All right, so as always, all right, so what type of the math or statistical background we need in order to solve it? So here, so we said if x is here is a geometric, right? So with p is here. So if x is geometric, then we know the PDF of x, not a PDF, this is a discrete, we say the PMF of the x here, it will be here, will be what? Will be 1 minus p to the x minus 1 and times p. So where the x could be 1, 2, 3, dot, 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 dot. Okay, so for this problem here, that's what is the goal we want to prove. If x is geometric, so I hope that I can find the probability of the x equal to any number k, you will be able to write into these forms here. Okay, so now let's take a look how we approach this problem, because they tell us, so the given conditions here, right? So it's memoryless. So like I said, it's kind of go backward. So this is x equal to the n plus m, given that x greater than m. So this is what we call is memoryless. So this is a given, right? So it's x equal to m. Okay, so let's take a look. So let's just find a few simple. So let's say that here, the first situation is here. All right, so let's let m equal to 1, n equal to 1. A simple one here. So then what do I have here? I have x equal to what? X equal to 2. Given that x greater than 1, right? Just put it here. Then we say this one here is going to equal to p equal to x equal to 1. That's right. Okay, so I'm going to write this p equal to x1 later. Okay, so now I can use the conditional probability. So I know the conditional probability. So maybe I should put it in here also. So this is the conditional probabilities, right? So we know the conditional probability for A given B is equal to probability the P, then this is A intersect B. All right, okay, so now in here, so this is a probability x greater than 1. Okay, so then here, this is x equal to 2 and intersect right? X greater than 1. So we know the intersect. What does the intersect mean? That means and, right? So intersect is and. So, okay. So now in here, we say this is the probability X greater than 1. All right. So if X equal to 2 and X equal to greater than 1, so what is the here is X equal to what? Equal to 2. Right? So then we know from the definition, this things here, while I wrote here is probability X equal to 1, right? So this is a probability X equal to 1. All right. So now so in here, you can see here, this is a probability X equal to 2 will be equal to the probability X equal to 1 times the probability X greater than 1. Okay, so because X is a discrete random variable, remember that the problem said X is belong to the n is equal to the 1, 2, 3, the natural number go all the way to here. So so I know if I summation probability X equal to I, so I from 1 to infinity, if I add all these probabilities together, what are going to have here? We're going to have 1. Correct? So the probability X greater than 1, so that means it's a probability X equal to 2 plus probability X equal to 3, right? And da, 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 da. So this one's really become 1 minus the probability X equal to 1, right? So the only item I did not add is probability X equal to 1. So now I will have a probability X equal to 1 times 1 minus probability X equal to 1. Okay, and so to be, to instead of writing, so the X equal to 1, okay, so instead of keep writing here, now I will let, okay, so let's see here, I will let the P is equal to the probability X equal to 1. All right, so to simplify the writing, so I know the P2, X equal to 2 will be just P times 1 minus P. Okay, now let's take a look. Second case here, let the M still 1, right? So M still is 1. Now let's take a look at A equal to 2. What is our situation? So based on this formula, so it's X equal to 3, given that X greater than 1, I know it's going to be equal to probability X equal to 2 here. That's what is given, right? So my left-hand side, I use the conditional probability again. So this is X greater than 1. This is a probability X equal to 3 and X greater than 1, right? So I know this will be X greater than 1. So probability X equal to 3 and X greater than 1 will be what? Probability X equal to 3 times probability X equal to 2. All right, so all right, so I'm sorry, so this is equal, right? So it's equal to the probability equal to 2. So now I can say here the probability X equal to 3, right? So the equal to 3 is equal to the probability X equal to 2 times the probability X greater than 1. So the same argument, probability X greater than 1. So this is X equal to 2. What is greater than 1? It's 1 minus X1, right? So this here, this is the key things here, right? So probability X greater than 1 is equal to the 1 minus probability X equal to 1. And also I assigned equal to 1 is equal to P. So this is 1 minus P. Okay, so from here, what is the probability X equal to 2 here? Oh, here is a P minus P, so I can substitute this is a P, 1 minus P, and times 1 minus P. So what I have here, I have wow, it's 1 minus P to the square to the P. Oh, wow, it's almost kind of the match what my formulas, right? So now I need to prove in general it's true. Okay, so how do I do that? I need to use the inductions, right? So I need to do the induction proof. Okay, so now let x equal to k minus 1, right? So that means true, all right? So let's say x equal to k minus 1. So let's do this. Okay, so let's say here, let p, the x equal k minus 1, okay, given that x greater than 1 is true, all right? Okay, so this one, if this one is truth here, so now let's see here, the probability x equal to this will be k minus 1 minus, so this will be k minus 2 plus 1, given that x greater than 1, right? Okay, so this is what? This is my n, and what is here? This is my m's, right? So let's give the inductions here. We say this is true, right? So this will be equal to the probability x equal to the k minus 2. So let's say this is so this one's here. So I'm sorry, this is k minus 1 here. All right, so here, be careful, k minus 1. So this will be okay. So this is okay. So this is k minus 2. So that's why we can prove we said probability x equal to the k minus 1 is equal to p, the 1 minus p, the k minus 2. Let's say if this is true, right? So given the x equal to x k minus 1, if this is true, I want to prove the x equal to k is true. Okay, so go back to your previous here. So see here. So here you see here, right? So when x equal to 3 here. So that's why I can prove that x equal to 3 is equal to 1 minus p. This 2 is 3 minus 1, right? Okay, so it's the same things here. So when x equal to the k minus 1, so it's p times 1 minus p. So this is k minus 1, right? K minus 1 minus 1. So let's say if this is true, we need to prove the probability x equal to k will be true, right? So now how do I prove that? Okay, so let's see here. So x equal to k, right? Given that x greater than 1, I can rewrite this. So this is probability x equal to k minus 1 plus 1, given that x greater than 1. So what is my n's here? This is my n's, right? And what is my m's here? This is my m, so this is my m. And because this is given, right? So I know because it's memoryless, so what is this one going to give equal to? This is equal to x equal to the k minus 1 here, right? So this is from what we just is given the memories. Okay, so now this one here, I can use the conditional probability x equal to the k minus 1, okay, x equal to the k minus equal to k. So here, okay, so this is x equal to k. Okay, so here I can use the conditional probability. I'm sorry here. All right, so here, from here, I can use the conditional probability. I would say x is greater than 1, then this is x equal to k, intersect x greater than 1, right? So the k intersect when x equal to k, k greater than 1, so that means I have x equal to k. Then this is probability x greater than 1. because I know this size here is equal to x equal to the k minus 1 here. So by inductions here, so I know this one's here by inductions from here, right? So this is p 1 minus p to the k minus 2. Okay, so now I know that x equal to k will be equal to the probability x greater than 1 times 1 minus p k minus 2. X greater than 1, like we say, is 1 minus p times p 1 minus p k minus 2. So that will give you 1 minus p to the k minus 1 times p. All right, so now I proved it, right? So that's why I proved it. So I from here, I proved, so what I proved here, p equal to k is 1 minus p to the k minus 1 to the p's here, right? So this is, so x equal to k is equal to 1 minus p to the k minus 1 and the p's here. Right? So this is geometric. This is the geometric, the PDF. Right? So K here can be what? Can be 1, 2, dot, 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 dot. So that is how do we prove it? All right. So it's kind of a very interesting, like I said, we used to is give you the distribution, want you to prove the memory list. And these ones here go backward. Is they give you the memory list and want to prove it's geometric. So that's why we need to use the induction theory and the C. And of course, you here be very careful. I think some teacher will be very picky. So what is P? You need to say the P here is how do we define? Is x equal to 1. Right? So the before here, that's how do we define the P is equal to the x equal to 1. So this is the geometric. So this is a geometric PDF, CDF. I shouldn't say, I always use the PDF, it's a PMF, right? So really that shouldn't, so it's a PMF. So this is a PMF with the P. What is the P defined? Is P equal to the x minus 1. So don't forget to include this condition in there, all right? All right, that's it. And I say it's a very fun problem to solve, okay? So nice, so talk to you in our next problem here, okay, bye.